Hello, it's Brian with Old Radio Troubleshooting. I will be putting out a video soon on troubleshooting an old GE vacuum tube radio. And while working on that, the rectifier tube, a 35W4 half-wave rectifier, seems to have been burned out. And so I want to take a little time today to look at that tube with the multimeter and see what we can find out about it. Okay, I have here a drawing of the 35W4 diode, the half rectifier tube, and the GE radio that I had mentioned. This is the view that you'll see on internet sites, or if you look in a manual or some kind of data sheet on a tube. If you're not familiar with them, this is how it's going to look. And this is as if you were either looking at the bottom of the tube socket working on the radio from the bottom, or it's the same orientation as if you were looking at the tube itself at the pins of the tube. So in this particular case, we have 7 pins. Not all of them are being used though. Pin 1 and pin 2 are unused in this case. And then one thing that we want to look at is the heater that runs through the tube. 3 and 4 are the heater pins, and you can see that they are connected. And they also have a tap coming off of the heater to pin 6. So 3, 4, and 6, if we use our multimeter, should all give us continuity. It may not be a dead short continuity. There's going to be resistance, but nonetheless, they should have continuity between those pins. Now, in this particular case, pin 5, which is the plate, is completely isolated. It should not show continuity to any other pins. And pin 7 is the cathode, and the same thing. It's isolated as well in terms of the other pins in this tube. So we would look for 3, 4, and 6 having continuity. 3, 4, and 6 not having continuity to either 5 or 7, and lastly pins 5 and 7 not being shorted together. So those are the kinds of things that we're going to be looking for with this tube. Now, a lot of people have a tube tester, and I have myself, which I actually tested this tube on, but I didn't always have a tube tester. And if you don't have one, there are certain tests that you can do with a multimeter. Not perfectly, but it'll show these basic issues quite well. So let me bring my multimeter into the frame here. And I've got 2 35W4s that we can look at. One is burned out. And okay, so let's start with this tube that I believe is burned out. And we'll take one of our leads, our test leads, and count clockwise. 1, 2, 3. We'll place it there. And then the next one up is pin 4. So we'll place the other lead there. And as you can see on the multimeter, there is no continuity. And so we're going to set that tube aside. That's the one that came out of the GE radio that I have the video coming up soon on troubleshooting it. Now let's go to a new old stock tube and do the same thing. We'll count clockwise. 1, 2, 3. Test lead there. And then another one on 4. And there we have continuity. Looks like we have 47.2 ohms. So while we have the tube available here and the multimeter set up, let's go ahead and check and make sure that 3, 4, and 6, which all have continuity, are not shorted to the plate at pin 5. Or to the cathode at pin 7, and finally make sure we have no continuity between the plate at 5 and the cathode at 7, because if we did, that would be bad. They would be shorted. So it'll just take a moment to make those checks. So let's go back and put our test lead again on 3. And we will go to the plate at 5. And good, there's no continuity there. Now let's go to the cathode at 7, from the heater at pin 3 to the cathode at pin 7. No continuity. That's great. Now we'll leave the one on pin 7 and take the one off the heater and bring it to pin 5 to make sure that pin 5 and pin 7, that is the plate and cathode, are not shorted. And they are not. There's no continuity there. So from these simple tests on the multimeter, this 35W4 diode half-wave rectifier seems to be in good shape. So it's going to be going back into service in that General Electric radio that I mentioned that I'm doing a video on, and hopefully it'll help bring that GE to life.